Okay, part 3. Number 14, an angle theta is in the standard position and its terminal side passes through the point -4, 5. Find the exact value of sine. So I know the point that this passes through, so I'm going to sketch this, left 4, up 5. So that means that we have this, that was bad. This side has a value of -4, because that was the x value of my point. And then this side has a value of 5, because that was the y value. So I can sketch my triangle, throw in my theta, so then we can find the missing side of our triangle by using the Pythagorean theorem. So -4 squared plus 5 squared equals x squared. So that's 16 plus 25 equals x squared. You can go to your calculator. 25 plus 16 is 41, and 41 is not a perfect square, so square rooting that is not going to be pretty, so we're just going to leave it. So x equals the square root of 41. I can throw that on my triangle and then figure out what this is asking. It says find the exact value of sine. Well, sine, that is opposite over hypotenuse. So opposite of my angle is the 5, and then my hypotenuse is the square root of 41. So sine of theta equals 5 over the square root of 41. And then just check your ASTC to make sure your sign is correct. In quadrant 2, sine is positive. This is positive, so that means I'm done. That's my answer. Number 15. The height h of t in centimeters of a piston is given by the equation h of t equals 12 cosine of pi over 3 t plus 8, where t represents the number of seconds since the measurements began. Determine the average rate of change in centimeters per second of the piston's height on the interval from 1 to 2. So hopefully you remember rate of change is just your slope formula, and these are telling you your x values, or in this case t values. So I just need to find my y values that correspond with those x values. So h of 1 I need to figure out, and h of 2 I need to figure out. So we can go to, you can type this into y equals, or you can just plug it in. I already typed it into y equals on the calculator. So if we go second graph to get to our table, we just need to find 1 and 2 to see what the x values, or the y values are. So 1 has a y value of 14, 2 has a y value of 2. So h of 1 equals 14, h of 2 equals 2. So then my rate of change, so my average rate of change is just the slope formula. So y2 minus y1 over x2 minus x1. So 2 minus 14 over 2 minus 1. Because these are my y values. And these are my x values. So I get -12 over 1. So that's our average rate of change. And then it says, at what values of t to the nearest tenth of a second does h of t equal 0 on the interval from 1 to 5? Justify your answer. So I just need to see where my graph is on the x-axis. So on your actual physical calculators, you can do second calc or second trace to get the calculate and then calculate the zeros. But on the app, that doesn't really work, because if you press calc, there's no way to calculate zeros that I've figured out. So we're just going to use the trace button. So if you hit trace, you can draw or move this little cursor around, and we want to see where it crosses the x-axis. So you can see at the top it's about 2.2. If you look at the top middle of the screen, it says x equals 2.2, well 2.19, whatever, so it rounds to 2.2. And then over here, this x value is 3.8. So we have t equals 2.2 and t equals 3.8. My dog is snoring next to me, and I'm really sorry if you can hear that in the video. Number 16, Griffin is riding his bike down the street in Churchville, New York at a constant speed when a nail gets caught in one of his tires. The height of the nail above the ground in inches can be represented by the trigonometric function f of t equals negative 13 cosine of 0.8 pi t plus 13, where t represents the time in seconds since the nail first became caught in the tire. Determine the period of f of t. Interpret what the period represents in context. So whenever it's telling me in context, that means that I need to be using what the word problem is actually talking about. So your period, you find that by using the formula that we learned. So period equals 2 pi over b. We know that my b value is 0.8 pi. So the period equals 2 pi over 0.8 pi. My pi's cancel, so I'm just doing 2 divided by 0.8. So 2 divided by 0.8, and I get 2.5. So that's my period, it's 2.5, and now we have to explain that in context. So this is talking about a wheel and a nail. So the period means that the wheel rotates completely around once every 2.5 seconds. Because you have this wheel and he drove over a nail. I'm going to draw the nail. So the wheel, because he's still riding his bike, is going all the way around. So once that nail gets back up to the top, it's been 2.5 seconds. So every 2.5 seconds, that nail is getting back up to the top of the tire. Or if you drew it another way, say the nail you started at the bottom, well then every 2.5 seconds, that nail's going back and hitting the pavement every 2.5 seconds. On the graph below, graph at least one cycle of f of t that includes the y-intercept of the function. So we can't have negative in this question because we're talking real life measurements here. So I'm not going to leave room for any negative. Just labeled that as the wrong letter. So we have our x-axis and our y-axis. My midline is 13. We see that from the equation. So I'm going to label these by 2. I'm actually going to stop at 26 because I know that if my midline's 13 and my amplitude is 13, my max is 13 plus 13, which is 26. And my min, that's 13 minus 13, so that's 0, which is why I said we can't have any negatives here because we're talking real life stuff. So, measurement, I mean. Now I need to label just my 4 sections, which I know I'm going to spread it out because every time we do one cycle of a graph, we just need our 4 tick marks. And it says my period is 2.5, so I'm just going to label that last tick mark as 2.5. You don't have to worry about the tick marks in the middle as long as you have that last one labeled with whatever your period is. Now this is a negative, it's a negative cosine graph, so this is going to start at the minimum rather than the maximum. I'm going to label in my midline here, so be right here at 13. And I'm good to go now. So I have my minimum, because negative cosine graph starts at the minimum. Then I go to my midline, then up to my maximum, back to my midline, and finally, after one cycle, we're ending back at the minimum. And that is one cycle of this graph. It does ask one more question. It says, does the height of the nail ever reach 30 inches above the ground? Well, we see that our maximum is right here at 26, so 30 is higher than that, therefore this will never reach 30. So we just say no because the max value is only 26. Number 17. Show that secant squared x minus 1 over secant squared x is equal to sine squared x. So the first thing we're going to do is split up this fraction. So I'm going to do secant squared x over secant squared x, and then 1 over secant squared x. So secant squared x over secant squared x. Again, I'm just splitting up the fraction. Minus 1 over secant squared x. And we want to show that this is equivalent to sine of x. So this needs to equal sine of x, or sine squared of x, sorry. So I can relabel these because I know that secant squared x divided by secant squared x is just 1. And 1 over secant squared x is cosine squared x, because secant and cosine are inverses. And then from here, this is one of our identities. This comes from cosine squared x plus sine squared x equals 1. Except instead of having the 1 by itself, we have the sine squared x by itself. And you get that by just subtracting cosine squared x on both sides. So it is true that this equals sine squared x. So we did it, sine squared x equals sine squared x. Remember, with problems like these, you always want to end the question with the left side equaling the exact same thing as the right side. There are multiple ways to do every single one of these types of problems. Number 18, write an equation for a sine function with an amplitude of 2 and a period of pi over 2. On the grid below, sketch the graph of the function in the interval 0 to 2 pi. So I've got the amplitude A. I do not have my b value. Instead, it tells me my period. So I have to use the formula that we learned to get the b value, because in order to write the equation, we need y equals a sine of bx plus c. Since it's not telling me anything about the midline at all, I can assume that that's 0. I do need to find b. So period equals 2 pi over b. My period is pi over 2, because that's what the question says. So then I just cross multiply to solve this. So I get pi b equals 4 pi. Divide by pi. So b equals 4. So my equation is y equals the amplitude of 2, it already told us, sine of 4x. This tells us, your b value tells you how many cycles occur from 0 to 2 pi. So 4 cycles from 0 to 2 pi. So when this is asking me to go from 0 to 2 pi, that means I'm going to have 4 complete cycles of this graph. So I have my y-axis, my x-axis, 4 complete cycles, so that's 1 cycle, 2 cycles, 3 cycles, and then 4 cycles. That's when I get to 2 pi. My midline we can assume is 0 because it doesn't tell us. My maximum is 2, which means, well, my amplitude is 2, which 0 plus 2 is 2, and 0 minus 2 is negative 2. So I can just start this graph. Starting at my midline, then every 4 lines I need to be back at the midline because we need 4 complete cycles here. So we go max, mid, min, mid, max, mid, min, mid, and then max, mid, min, mid. Finally, we end at 2 pi. So that is 4 cycles because we needed to go from 0 to 2 pi. The next video where I finish the last 2 questions will be very short. I'm